Hello, dear students. Welcome to BYJU'S Exam Prep. I welcome you all, guys, uh, to this particular session. So, in this session, guys, basically we will discuss the GATE expected question, which is designed by me, right, for your examination. And in this particular session, I will discuss environmental engineering, structure part, RCC part, as well as some of the questions which is from engineering mechanics also. So guys, before starting the session, please share this session to other student also so that they can join over here, and then we will start our session. Okay, and let me share the session also. Okay, and please let me know, guys, audio and video is perfect from my side or not. Just let me know audio and video is perfect. Aman, good afternoon. Ritu, good afternoon. Rahul, good afternoon. Come fast, guys. Come fast, come fast, come fast. Come fast and join the session. Let me share it on the Telegram so that everyone can join, guys. Okay, just a second. Okay, let me share it. Okay, done from my side. Okay, guys, good afternoon, Ritik. So guys, let's start the session. Okay, so as I told you earlier also, in this particular session we will discuss the question from environment part, structure part, RCC part, and engineering mechanics. Okay, so these four subjects I'm covering over here because you know that, guys, in the last session, due to some technical issue, I'm not able to take that particular session on a continuation basis. That means a 51 question, right? So I'm compensating that particular session from this session, guys, and you can understand I have planned 30 questions for you so that you can enjoy the session completely. Okay, so let's start the session. Okay, guys, let's start the session. Okay, so those who are new over here, guys, let me tell you about myself. My name is Krishna Yadav, and I'm a mentor, right? And I'm teaching from last 8+ year, guys, right, for these particular examination like GATE and EAC. And I have done my masters from IIT Roorkee, and these are the subjects in which generally I deal, and all the subjects I have taken in this particular session also, right? So guys, those who have not subscribed our channel, please subscribe it, okay, and hit the like button also. You can join the non-stop marathon also, guys. These are the dates which you can follow. And this is one of the mega workshop for your GATE aspirant like 2023. So you can join this particular also, guys, right? So this is the first question in front of you, guys, and please start solving this problem and let me know the correct answer. Which particular answer is correct in this particular question, right? This is the question number 1 in front of you, which is based on single degree of freedom, and this is basically based on your vibration part, right? And you know that, guys, the vibration part is very important because last year it was added, and it may be possible you may get the question in this year also because IIT Kharagpur will get a chance to plan a question for you, right, this year from that topic. So just solve it and let me know the answer. A cantilever beam of length L carries a mass M at its free end suspended by a spring of stiffness K, right, which is shown in the figure. Now the equation of motion of the system is, what will be the equation of motion? Let me give you one hint over here, guys, so that you can understand how you can solve it. Okay, just what you have to do over here, guys, this is basically the equation of motion for single degree of freedom, right? Mx double dot plus K equivalent into x is equal to 0, which you can write in this way also, like mass double derivative of x, which is basically displacement, nothing else, plus K equivalent and x, and it should be equal to 0. Now your task is to find out the K equivalent value. That's it. Okay, Mayank says sir D hoga. Okay, Mayank, very nice. What other student says? Tell me, guys. What other student says? Mayank D, very nice, Mayank. हेलो संतू, हाउ आर यू, कैसे हो जी? आते जाए बच्चों, आते जाए, कम फास्ट. Gorvi D, very nice, Gorvi D. Ritik D, very nice. Ritu D, very nice. I will explain the question in detail also, right? So those student who don't know about this, I will explain it. Okay, no issue. So this one is what? This one is our single degree of freedom, right? Which is basically our equation of motion. Equation of motion for single degree of freedom, right? Now our task is, in this particular case, we need to find out the K equivalent value. And you can see here, guys, this is a system which is given to us. But how we can understand whether there is a series combination or a parallel combination? So let me give you one hint so that you can understand it and you can solve it also in the examination. Okay. Okay, so let me tell you one thing over here, guys. So first of all, you need to draw a free body diagram. Okay, so this is our structure which is given to us. This end is fixed. Okay, and this is also a spring, right, which is also connected with this particular beam, and the mass is given to us. This is basically m. Now you have to see here, guys, if I break this particular part, right, so what will happen? The tension force is to be generated in this particular, or you can say that, guys, the tension force is generated in this particular spring, right? So the same force is to be applicable over the beam also, right? Or we can consider this particular force as the F, and this one is also F. So you can see here, guys, we can say that in this particular mass or in this particular spring system, we have a force F, and the same force is to be applicable over the beam. So we can say that, guys, this particular combination is a series combination. Whenever you have same amount of force, then it is a series combination. When you have same amount of displacement, then it is parallel combination. Now this one is series combination. Now just imagine, guys, this one is what? This one is our stiffness of the beam, right? And this is nothing else. This is the stiffness of the spring. So whenever you have a series combination, please remember this particular point. Whenever you have a series combination, for series combination, how you can find the K equivalent? So 1 by K equivalent is equal to 1 by K beam plus 1 by K spring, correct? Now just you have to solve it so that you will get this particular value of K equivalent. So it will be 1 by KB multiplied by K spring, and this value will become K beam plus K spring, right? And the final value will become K equivalent is equal to K beam into K spring divided by K beam plus K spring, correct? Now this is nothing else. This is basically series combination. Now just imagine, guys, if you have a parallel combination. So in that particular case, what you have to do? You have to just add the stiffness directly, right? In that particular case, just add or just take the addition like KB plus KS, right? That will become the stiffness in case of parallel combination. But which combination is parallel? In which the displacement is same, correct? Okay, so I think now you are able to understand. So just you have to put this particular value over here. So this particular answer will become mx double dot plus the stiffness which is given to us, that is basically K beam, K spring divided by K beam plus K spring. Multiply by what? Multiply by x, and it should be equal to how much? It should be equal to 0. So this will be the answer. That's why D is the correct answer for this problem. Okay. Good afternoon, Harita. Okay, next question in front of you, guys. Next question. This is MSQ. Please, careful, guys. Okay, this is MSQ question, right? In which you have to take multiple options over here, not a single option, multiple options over here, right? Chaitya, I'm good. I hope you are also good. Okay. Now tell me the answer of this one, guys. Which of the following statements are correct? You have 4 options over here. Kindly check it and let me know the answer. Quickly solve it, quickly solve it, quickly solve it. Quickly solve it, guys, quickly solve it. And let me know the answer. Which particular option is correct? We have basically 4 options and this is MSQ. जंग है, बड़ी है भाई MSQ की भी, है ना? तो MSQ का आंसर बताएं क्या होगा बच्चों? All. अरे बाबा रे बाबा. Mayank says all. Santu say all. Oh. Be careful, guys. Be careful while reading the question. Be careful, okay? This is MSQ. Okay, let me explain it so that you can understand it. Okay. So the first option, when there is a reduction in the amplitude over every cycle of vibration, then the body is said to have damped vibration. What it means, let me show you one graph so that you can understand. Let me show you one graph. Just check it out, guys. This is basically our displacement on the y coordinate, and on x coordinate we have a time duration, correct? So this is plus x and this one is minus x, which you can consider positive displacement and negative displacement, and this particular position is a mean position. So what happened when the vibration is occurring? So what will happen, guys? The amplitude is what? That is nothing as maximum displacement which can occur, right? So this particular amplitude is continuously what? Continuously decreasing in case of damped vibration. Now let me tell you one very basic example so that you can understand. I think guys, all of you have seen the guitar, right? If you give a stroke over the string, so what will happen, guys? It will vibrate for some duration, and after that it will reduce its oscillation and ultimately come to the mean position. And in that case, you can say that the displacement is continuously reducing with respect to time period. That's why that particular type of vibration is known as damped vibration. So this particular option is correct, right? But in case of undamped vibration, right, what will happen? The amplitude will not get changed and it is to be constant throughout the time period. So that means you can see, guys, this particular curve will be like this, in which the displacement is constant, right? It is not changing. It is constant. It is constant. Understood? So this is known as undamped vibration. So this one is also correct, right? This one is also correct. But what about the C option? We have seen our equation. In C option, there is one issue. It is written as x double dot, which is wrong. And you know that, guys, in this particular case, it should be x double dot, right? You know that what is x double dot, what is x dot, what is x? X is displacement. X dot means velocity if you're taking the first derivative. If you take the double derivative, that means you are finding the acceleration part, right? So that means d2x divided by dt2, right? So in this case, the actual equation of motion is what? The actual equation of motion is mx double dot plus k equivalent x, and it should be equal to 0. That's why this particular option is wrong. Clear? Okay. Okay. Now, if we talk about the D option, we know that, guys, if we have a parallel combination, then the stiffness can be added directly, right? Someone is asking, sir, can you give a example for undamped vibration? So let me tell you, for undamped vibration, what you can do, just imagine, guys, if you have a vacuum room, just imagine, right? Imagine, this is the imagination condition. If you have a vacuum room, right? In that particular case, if you take a pendulum and release it, so what will happen if there is no any other force which can reduce the oscillation or which can reduce the amplitude part? So that particular pendulum continuously try to achieve its initial position continuously, but the room should be vacuum, right? In that particular case, there is no air, there is no oxygen, right? So that is the condition in which you can find the undamped vibration also. Okay, no issue, no issue, no issue. So that's why, guys, A, B, D are the correct answer. C is the wrong one. Okay. Let's move to the next part. Let's move to the next part. Again, be careful, guys. This is a question which is based on vibration part. And in this question, we need to find out the natural frequency, right? Which is basically 1 by 2 pi under root of K equivalent divided by mass. Now, in this case, again, you need to find out the K equivalent value, right? Now, tell me the answer, guys. Tell me the answer for this problem. Tell me the answer for this particular problem. What you have to do basically over here, guys, you need to find out the stiffness at the position or at the location where the mass is present. Okay. Yes, you can say that spring on a frictionless surface and we have a block, then it can oscillate continuously. Now tell me the answer of this one, guys. Now tell me the answer of this one. Very easy question, I think so. You can solve it quickly. Tell me the answer of this one. In this case, we need to find out the natural frequency of the vibration of the system. Correct? Okay, let me solve this particular problem also. And please solve it and let me know the answer also, okay? I'm also solving this problem. So guys, this is given to us, which is basically a hinge, right? And this is a rod and we have a mass over here, right? And this is a spring. So I'm cutting the spring over here, guys. So definitely we will have a force like this. Okay, so let us consider this is a spring force, which is Fs, and we know that this particular mass will have mg force, which is basically acting vertically downward. Let us suppose this distance is a and this distance is a. We know that this O point is the hinge. So can I say that the moment at point O should be equal to 0, correct? So we can write here, guys, mg into 2a minus Fs into a, and it should be equal to 0. So what is the value of Fs? Fs is equal to twice of mg. This is the one of the thing, guys, which we need to find. Okay. Now just imagine if this particular mass is trying to move in the downward direction. So what will happen? This particular rod will not try to bend because it is the rigid one, rigid bar. This bar is rigid bar, right? So what will happen? This bar automatically try to tilt in this manner. So what you will observe, let me show you that first. So what you will observe, guys, you will observe a triangular shape of this particular condition, right? So what happened? In the direction of spring, this is the basically location of spring. In the direction of spring, some displacement will be there, and let us consider that displacement is equal to x. And the displacement in the direction of mass is x1. Okay. Now this distance is a and this distance is also a. So can I write it down, guys? X by a is equal to how much? X1 by 2a, right? From this particular point, this distance is 2a, correct? So x1 is equal to how much? X1 is equal to twice of x. X1 is equal to how much? It is twice of x, right? Twice of x. You know that, guys, in this particular spring, there is some force, and that particular force is nothing as displacement into stiffness, right? That will become our spring force. So this spring force, we can write it is equal to how much? 2 mg is equal to kx also. And in this case, what will be the value of x? X is equal to twice of mg divided by k, correct? Now we need to put this particular value in this particular case, right? So what will be the value of x1? X1 is equal to how much? It is twice into x. X is equal to how much? 2 mg by k. 2 mg by k, correct? So it will become 4 mg by k, right? Now, guys, our task is to find out the stiffness, to find out the final stiffness, right? So you can see here, guys, in this particular case, can I write it down? X1 is equal to mg divided by k by 4, right? So what you will observe over here, guys, in the direction of mass, how much stiffness we are getting as a final value. So you can see here, guys, our stiffness will be k by 4, right? And this is our displacement in the direction of mass itself, and it should be equal to how much? Mg. So this is nothing as this is our k equivalent value, final value, k equivalent value, right? So you need to put this particular value in this equation, so you will get your answer. So the frequency can be written as 1 by 2 pi under root of k equivalent by mass. So k equivalent is equal to how much? That is k by 4 divided by mass, that is m. So which particular answer is correct? A or B? A or B? Tell me, guys. A. A will be the correct answer. A will be the correct answer. A will be the correct answer. Clear? Very good, Mayank. Very good. Now I think all of you are able to understand how to solve this particular problem also. Okay. Ultimately, you just need to find out the stiffness in the direction of mass itself, right? Whatever mass you have, right? You need to find out the stiffness in that particular direction. Next question in front of you, guys. This is basically based on truss, right? And you need to find out the force in member CD. That is the question. You need to find out the force in this particular member, which is basically CD member. Please find out. Please find out, guys. Okay, and let me know the correct answer. Which particular option is correct? Okay, be careful. This is a UDL which is given to us, right? Whose intensity is P, right? This value is already known to us. Solve it, guys. Solve it. Quickly solve it and let me know the answer. Very easy question, right? If you have a basic concept, then you can solve the problem quickly also. And I will tell you how to do the smart work in the exam also. Okay, right? In this case, we need to just find out the magnitude. Very simple, right? Tell me, guys. 0? Oh, oh. No issue, no issue, no issue. Let me solve it. Okay. Tell me, guys, this particular intensity is what? This intensity is P, correct? And the length is L. So can I say that, guys, the force which is acting at support A and at support B is equal to how much? That will be PL by 2. And this one is also PL by 2 because of symmetry, correct? Now you can observe over here, this length is L, which is height, and this particular length is also L. So definitely this angle will be equal to 45 degree. It is understood to all of us, right? Now, guys, our task is to find out the force in this particular member CD, right? So can I say that, guys, in this member, which is basically CE, the force will be 0. It is understood because we know that, guys, at this particular joint C, we have 3 member, out of which 2 are collinear, 1 is non-collinear, and there is no loading, no external load. That's why this particular member will have 0 force. But can I say that, guys, this force is FAC? Okay, if this is FAC, so this one is also FAC or FCA, one and the same thing. The same amount of force is to be applicable in FCD also. So it means that it doesn't matter whatever the direction is there, because in this question, we just need to find out the magnitude. That is our task, right? Nothing else. So our task is to just find out the magnitude. So guys, tell me, if you are able to find out the force in CD member, then you are able to get the answer for AC also. Or you can say that if you are able to find out the value of AC, that means you are able to get the value of CD also. Correct? So our task is to find out AC, not CD, right? We will find AC, same values to be applicable, right? So just need to draw a FBD. So this one is FAC and this one is FAE, correct? And this angle is equal to how much? It is 45 degree. Okay. So we know that this value is equal to how much? PL by 2. So first I will take the summation Fy is equal to 0 at joint A. Summation Fy is equal to 0 at joint A. So this value will become FAE sine 45 degree plus PL by 2 and it should be 0. Correct? Now FAE is equal to how much, guys? FAE is equal to minus PL by 2 divided by sine 45, or you can write it here, guys, 1 by root 2. Right? So ultimately what you will get, FA is equal to how much? That will be minus PL by root 2. This is one of the value which we need to find. Now, guys, our task is to find out AC. So can I say that summation Fx is equal to 0? Another equation, right? Summation Fx is equal to 0. So FAC plus FAE cos 45 degree. And it should be 0. So AE is equal to minus PL by root 2 multiplied by 1 by root 2. Correct? And it should be 0. And this is basically FAC. Just find out the value of FAC here. Very simple answer. PL by 2, PL by 2, PL by 2, PL by 2. So those who are saying 0, wrong here. Okay. Yes, you can find the value of CD also by taking section. But guys, we are trying to solve the problem in easy manner, right? So that we can get the answer logically correct as well as the solution is also correct, right? So logically, this answer is answer, right? Whatever value you are getting for AC member, the same value is applicable for CD also, right? So do not bother about it. Whatever the direction is there, tension, compression, let it be. Okay. Next question, which is based on friction force. Very easy question and little bit logical question, right? Ah, very nice, Kushagra. Very nice question you have asked. Sir, we are trying to apply the load always at the joint. Correct. I agree. Right? I agree. But in this particular question, you have applied a UDL over the length of member. That is the wrong part. But let me tell you one thing over here, guys. The UDL is not to be applicable directly like this over the truss, right? So what you have to do, you have to put some support or some roller thing, right? And then after that, you have to apply the UDL, right? But ultimately, the same effect you will get as we are getting in this particular question, right? So that is the logic, right? Let me show you that particular point also. So you can see, guys, this is our truss, right? And over which a UDL is to be there. So what you need to do, you need to place a like some member, okay, and over which we have a UDL, and that UDL is to be connected with some points, or you can say that some roller support. Okay, so ultimately this force can get transferred at this particular point, and this force get transferred at this particular point. Clear? I know that, aspirant, I know that. But I think you need to understand this particular point, because this question, listen carefully, this question was asked in the gate examination itself, but not in the civil engineering. It was asked in mechanical engineering paper, right? That's why I have put it this question also, right? Okay, so let's move to the next question. Okay, question number 5. Come back to the next question, guys. Okay, so in this case, what you need to do, you need to find out the minimum fraction of the rope that can be lie on the table without slipping over the edge. So just imagine, guys, if you have a table in your home, so what you need to do, you have to take a rope, okay? So some length of the rope, it's to be placed over the table, and some length is to be hanged over that, right? So what will happen, guys? Ultimately, it may be possible the rope can slip, or it may be possible the rope can be stable. So you need to find out the minimum fraction which we have to put over the table so that it cannot slip over the edge. That is the question. Okay. So very easy question, guys, and I will solve it completely also so that you can have a logic behind it. Okay. Based on engineering mechanics. Tell me the answer, guys. Tell me the answer. Anyone who got the answer for this question? Any one of you? Ganesh says sir B होगा. Okay, Ganesh. Aman say A होगा. Very nice, Aman. Mayank A होगा. Very nice, Mayank. Okay, very nice, guys. Okay, so let me solve this particular problem. So first of all, let me explain a small thing over here. We know that, guys, this particular length of a rope, this complete length, let me show you that. From this particular point to this particular point, the length is, let us consider total length is L. Okay, the total length is L. So let me write it L. And let us suppose the mass is capital M. Now just imagine, guys, certain portion of the rope is to be placed over the table, and that particular length is X. So what will happen? The remaining part will be L minus X, correct? Now just imagine guys, the mass of this particular fraction is small m. So the total mass is capital M. So what will happen guys? This particular mass will become m minus small m. Clear? So can I write it down guys? This particular fraction is x, which is placed over the table, and the mass is m. So can I write it down guys? Small m is equal to capital M into x divided by L. This is our small m value. Okay sir. Okay sir. Now what we need to do guys? We need to draw a free body diagram for both the parts. Okay. So let's move to the next page so that you can understand it. Okay. Just imagine guys, this is the portion which is placed over the table, and this is the portion which is hanged, right? So we know that guys, the mass is small m. So can I say that mg will be there in downward direction, and this rope has a contact with the table also. So we have a normal reaction in upward direction. We know that guys, there is a friction force also between the table and the rope, right? Because we have a friction coefficient also, which is basically mu, and this is given to us, right? So can I say that a friction force is to be applicable in a backward direction? So that is basically Fr. And we are considering this value of Fr as a limiting value. Why? Because we need to find out the minimum fraction over here. So that's why we need to write mu into n. And this is basically tension force which is acting over it. And this tension force is same as we are getting over this particular portion, right? So this is our tension force. And what will be the mass? This one is m minus m into g. Now guys, first I will write here the summation Fy is equal to 0 in this particular portion. So summation Fy is equal to 0 is equal to how much? T minus m into g is equal to 0. So the tension force is equal to how much? That will be m minus m into g. Correct? Now if we talk about guys this particular portion. So in this particular portion, what you have to write? First we need to write summation Fy is equal to 0. And that will be equal to n minus mg is equal to 0. So n is equal to how much? Mg. And you know that guys, we can write here the summation Fx is equal to 0 also. So summation Fx is equal to 0 means T minus Fr, and it should be 0. So T is equal to Fr. Fr is equal to how much? Mu into n. What is the value of n? N is equal to small mg, right? So this is the tension force which is occurring, and this is the tension force which is occurring, right? But both the tension force values will be same. So that's why we need to equate it. So mu into m into g is equal to capital M minus small m into g. You can cancel g to g. Now we need to place the value of small m. And what is the value of small m? M into x divided by L, right? So mu into capital M into x divided by L is equal to m minus capital M into x divided by L. We know that capital M is common. You can cancel it out. Okay. So first we will take the LCM. Mu into x divided by L is equal to L minus x divided by L. You can cancel this one. And ultimately what you will get guys, you have to take this particular x on the left hand side. So you can take out the common x. So mu plus 1 is equal to L. So what is the value of x? X is equal to L by mu plus 1. So this much length we need to put over the table so that it can be stable, right? This is the length, right? But our question is we need to find out the fraction. So how we can find the fraction? Fraction is nothing as the amount of length which is placed over the table with respect to total length, right? So x is equal to how much? X is equal to L by mu plus 1 divided by L. Cancel it. So ultimately you will get the fraction value. Fraction is equal to 1 by 1 plus mu. So this is the answer, right? So you can see here guys, A is the correct answer for this problem, right? Now I think all of you are able to understand the complete solution over here, correct? Okay, so let's move to the next question. Okay, let's move to the next question over here. Next question is MSQ, which is based on pre-stress concrete, And this is a question, guys, in which you need to find out the stresses at the top fiber and at the bottom fiber, right? But little bit calculative question, right? Little bit calculative. So you can solve it and let me know the answer. Solve it and let me know the answer. Solve it and let me know the answer, guys. What will be the answer for this particular problem? In initial part, I have put it some of the question which is little bit lengthy, little bit calculative, okay? But later on you will get a simple questions also, right? So these type of questions are basically 2-mark problem which may you find in the examination, right? But later on you will find some of the question which is basically 1-mark problem, and I will show you that, right? So just solve it. Guys, there are two conditions. One is initial condition and second is final condition. So be careful while solving the question, okay? In this case, they have given the net loss as a 20% and the final pre-stressing force, final, right? The value is also given as a final, right? That value is not initial value. Be careful. The final pre-stressing force applied at A is 500, right? After the losses has deducted from the initial value, this value will become the final pre-stressing force, right? Which is basically 500 kilonewton. So be careful, guys, be careful. Final stress is at the top fiber is 0 when greater than 75, when less than 70. Okay. Exactly, this particular options, which means this particular option and this option, right? The final stress at the top fiber is 0 when the eccentricity, let me write it, eccentricity, right, is greater than 75, and in this case when eccentricity is less than 75. Now this statement is complete. Done, guys? Okay, so let me solve it for you. So first of all, we need to see this particular diagram, which is our given figure, right? And then after that, we will try to draw the stress diagram also. So this value is 250, guys, 250 mm. And the overall depth is 150 plus 150, that is basically 300 mm, correct? And this is our cable, location of the cable. This one is 150. And this one is 75. This one is also 75. Okay, sir. So first, you know that, guys, we need to draw the stress diagram. So let us suppose this is P and this is E. Okay. So first I will try to draw the direct stress diagram. Direct stress is P by A. And both values are positive at the top fiber and at the bottom fiber, P by A. But due to this particular pre-stressing force, we have a bending stresses also. And due to which, guys, you need to understand at the top fiber, the tension is occurring, and at the bottom fiber, the compression is occurring. So what will happen at the top fiber, you may find the tension. So if it is tension, then it is negative. And if it is compression, then it is positive. So this one is positive, this one is negative, correct? So this value is equal to how much? It should be PE into Y by I, correct? Now our task is to find out the stress at the top fiber, right? At the top fiber, okay? So at the top fiber, the value will be P by A minus PEY by I. Now listen, guys. Listen very carefully. Our task is to find out the initial extreme stress at the top fiber. Initial means you need to find out the initial stresses, okay? So what you need to do, listen carefully. First, you need to find out the value of initial pre-stressing force. Initial pre-stressing force. So P into, let us suppose this particular initial pre-stressing force is P into 80%, because 80% is remaining part now. Let me remove this, okay? It should be equal to how much? It should be equal to 500, right? So can I say that, guys, the pre-stressing force is equal to how much? 500 divided by 0.8, and this is the initial value. 500 divided by 0.8, and this is the initial value, which is basically 625 kilonewton, correct? Now let's find out this particular value first. 625 multiplied by 10 raised to power 3 divided by cross section area, which is 250, multiplied by this total depth, which is basically 300, minus 625 multiplied by 10 raised to power 3 multiplied by 75 multiplied by y is equal to how much? 150, divided by I is equal to how much? BD cube by 12. So B is equal to 250, D is equal to 300 cube divided by 12. Now just you need to solve this particular value and let me know the answer, guys. Okay, I know that, guys, little bit calculative, but if you are doing this type of calculation in the examination with patience, so you will get the benefit of such type of practice, right? क्योंकि हमारे अंदर पेशेंस ही तो नहीं है भाई, सब कुछ है. ओके how much you are getting, guys? How much you are getting? This is 12.5. If you solve it, 8.33 minus ans. So we are getting a value of minus 4.17, right? Megapascal. Kindly check it and let me know the answer. Yes, yes, minus 4.17 megapascal. So this answer is wrong, right? This answer is wrong. This answer is wrong, correct? Now the next problem is we need to find out the final extreme stresses at the bottom fiber, right? So at bottom fiber, what will be the value? What will be the value? Let me show you that part also. Okay, just a second, guys. I am hiding myself so that I can write in that particular space. Okay, just a second. Okay, let me hide myself. Okay, now if we talk about, guys, the value which is available at the bottom fiber, but bottom fiber we need to find out the final stresses. Final means we need to consider the force as a 500, not 625. So for final value, this will be 500 multiplied by 10 raised to power 3 divided by area 250 into 300 plus P again 500 multiplied by 10 raised to power 3 multiplied by 75 multiplied by y is equal to 150, correct? Now divided by I is 250 into 300 cube divided by 12. Now just solve it and let me know the answer for this one. Guys, this particular value is coming 6.66 plus. Next one is 500 multiplied by 10 raised to power 3 multiplied by 75 multiplied by 150 multiplied by 12, then divided by 250 multiplied by 300 cube. So we are getting a value of 10. Kindly check it. Kindly check it. Why we are not taking the formula P square? Because we do not have to find the stresses at the level of steel, right? If you have to use that formula, which is PE square by I, in that particular case, you are trying to find out the stress at the level of steel or at the level of cable. Our task is not that. Our task is to find out the stress at the extreme. That's why Y should be equal to how much? D by 2. That is the reason, right? So this value is 16.67 megapascal. So this answer is also wrong. This answer is also wrong. Okay. Now the question is, what about this two answer? These two answer. Okay. So guys, as per this particular statement, the final stress at the top fiber is 0 when E is greater than 75 and E is less than 75, then it is 0. Okay. So just check it out. Just check it out. Can I say that, guys, P dash, which is about 500 divided by area minus PEY by I, and it is equal to 0. Okay. Now you can check it out, guys. Listen carefully. If we equate it, if we equate it, so P dash by A is equal to P dash E by I. Okay. If we cancel these two things, so ultimately we are trying to find out the value of E. Okay. So E is equal to how much? I divided by AY, right? So listen carefully, guys. What is the value of I? I is equal to 250 into 300 cube divided by 12 divided by area. Area is 250 multiply by 300 multiply by y. Y is equal to how much? 150, correct? Now just solve it and let me know the answer. You can cancel this particular value. 250 cancel, 300 cancel, it will 300 square. So 300 square divided by 12 and 150. Okay. So how much we are getting? E is equal to 50. E is equal to 50 mm. How much we are getting? E is equal to 50 mm. Now tell me, guys, out of these two options, which option is correct? Out of these two options, which option is correct? Tell me. C and D. We are getting E is equal to 50. E is equal to 50. E is equal to 50. So the final stress at the top fiber is 0 when eccentricity is greater than 75. It should be less than. So guys, what happened in this particular problem? We are getting only a single answer as a correct answer, right? So we have to go with the correct option, right? Do not try to put a wrong answer over here, whether it is MSQ, whether it is MCQ, right? So be careful. If you are getting only a single option as a correct answer, please try to put that only. Okay. Do not make it multiple also, right? Like मुझे तो बोला था MSQ है, एक से ज्यादा होगा, वैसे तो आपको एग्जाम में मिलेगा ही एक से ज्यादा. But guys, this is a question which is trap for you, right? From my side. That's why I'm telling you, you need to give your focus 100%, right? So whatever correct answer you are getting in this particular case, the answer is that only. Okay. D is the correct answer. Next question. Next question. A simple one. A simple one. In 2 lines, you can solve this particular problem. In 2 lines, right? In 2 lines, you will solve this particular problem, guys. Only in 2 lines. Very simple question. Just you need to find out the design load, right? Design load. Tell me, guys, which particular answer is correct? You need to find out the design load for the slab. 24. Very nice, Santu. Very nice. Guys, in this question, they have given the live load, right? So the live load is 10 kilonewton per meter square. Second, we know that, guys, in this case, the finishing load is also given, which act as a dead load, right? So we can write it 1 kilonewton per meter square. But what about dead load? Actual dead load or self weight of the slab. So for 1 meter square area, we need to find out, right? So can I write it down, guys? 1 cross 1 cross. What should be the thickness? That is basically 200. So we can write here 0.2 multiply by how much? That will be 25. Okay. So just add it and let me know the value of total load. So 1 into 0.2 into 25. So we are getting 5 plus 1 plus 10. So that will be equal to 16. Now we know that this particular load is a combination of dead load plus live load, right? If it is the combination of dead load and plus live load, so we need to multiply a factor of safety, that is basically 1.5. So let's multiply it 1.5. So you are getting a value of factor design load as the 24. Correct? So B is the correct. Next question, very important. In this problem, you are able to understand how to solve the stress block parameter. And if you know the answer, please let me know. Otherwise, I will solve in front of you so that you can understand how to get the answer for this particular problem. You need to find out the depth of neutral axis from the compression fiber. Find out the depth of neutral axis from the compression fiber. Solid? I'm also solving, right? So let me read the question first so that you can understand it. Okay. Now, assuming a straight line instead of parabola. Generally, we are trying to consider a parabolic and a rectangular part, right? So in this case, we are considering a straight line, right? Instead of parabolic portion in case of stress block parameter. As well as we are considering the partial factor of safety as a 1, right? The partial factor of safety is 1. A rectangular under reinforced concrete section of 300 mm width and 500 mm effective depth is reinforced with 3 bar of grade Fe415. Now each of 16 mm dia, right? And the concrete mix is M20. Okay. The depth of the neutral axis from the compression fiber is, our task is to find out the depth of neutral axis from the compression fiber. So first we need to draw the figure, right? Then only we can understand. Okay. So let me draw it. Okay. So we have a cross section of a beam. We have a cross section of beam over here, right? And this cross section of beam have a dimension of 300 mm. Next one is 500 mm as an effective depth, not an overall depth. Okay. Okay, sir. Now 3 bars of 16 mm dia. 1, 2, 3. Okay, ji. Any other thing? No. So let me draw the stress block diagram. Stress block diagram. Okay, ji. Okay, ji. Okay, ji. So this is our stress block diagram, right? Okay. So this value is already known to us, 0.67 FCK. Correct? Okay. 0.67 FCK. Okay. And this is basically XU. This is basically XU. Correct? And this one is how much? This one is D minus XU. D minus XU. Okay. Now guys, listen. Listen. In this particular problem, we need to find out the forces. This is our C1 force and this is our C2 force, right? And this is our T force. Now the problem is we need to find out this particular portion of depth and this portion of depth, which is X1 and this one is X2. How we can find it out? By using strain diagram. So what you will observe guys, the strain value is already given to us. At this level, the strain is 0.0035 and the strain at this particular level is 0.002. Correct? Okay, sir. Now what you can do over here guys, what you can do, first you need to use this particular triangle to find out the value of X1 and X2. Okay, so can I write it down guys? This is basically X2, right? This one is X2. So X2 is present at a level of 0.002 and the total value of depth, which is basically XU, have a strain of 0.0035. Correct? So X2 is equal to how much? 0.002 divided by 0.0035 multiplied by XC, right? So how much we can write it? 4 by 7 XU, 4 by 7 XU, correct? Kindly check it. Yes, 4 by 7 XU. If X2 is 4 by 7 XU, then X1 is equal to how much? It will be 3 by 7 XU. 3 by 7 XU, correct? Now I think you are able to understand the value of x1 and x2. The value of x1 and x2. Okay, sir. x1, x2 is known to you. Now the question is, we need to find out the force C1, C2 and our T force. So we know that how to find out the value of XU by equating the forces. C1 plus C2 is equal to T. So what is the value of C1 force? C1 is equal to nothing as, you need to take the average of this particular stress and then multiply by the area under this particular stress diagram, right? So this much area is there, right? Up to which depth? That is basically X1. And the lower one is, so can I write it down, guys? The average stress is 0.67 FCK, 0.67 FCK plus 0.67 FCK. We are trying to take the average of stress value, divide by 2 at the upper part, and at the lower part the same value is there. That's why it is average value, multiply by area under this particular stress diagram. So how much area will be there? That is B into x1. So B is equal to how much? वो हम बाद में देख लेंगे, ठीक है? x1 is equal to how much? x1 is 3/7 xu. Okay. Plus what is C2 force? Again average stress. So average will be 0.67 plus 0 divided by 2. 0.67 FCK plus 0 divided by 2 bracket multiply by area B into x2. x2 is equal to how much? 4/7, correct? xu. And this is equal to 0.87 fy into a. Now just put all the values to get the answer. Guys, it is little bit difficult for me to write on the PowerPoint, right? Generally, I'm using open board to write it properly, right? But in case of PowerPoint, my writing is not too good. ठीक है, मेरी writing अच्छी नहीं है, but concept अच्छा है ना? और logic अच्छा है, right? So I am providing that particular thing mainly, right? But if you find any difficulty while reading the written part, please let me know. I will explain it. Okay, no issue, right? So very simple. Okay, so just need to put the values over here. So 0.67 FCK, the final value will be 0.67 FCK. FCK is equal to how much? FCK is 20. Multiply by B. B is equal to how much? B is 300. Multiply by 3/7. Multiply by XU. We don't know. Plus 0.67 FCK. FCK is 20. Divided by 2. Multiply by B. B is equal to how much? B is 300. Multiply by 4/7. Multiply by XU is equal to 0.87 FY. FY is equal to how much? 415. AST. AST is equal to how much? 3 bar we have. 3 into pi by 4 into 16 square. So just solve it and let me know the answer. XU is equal to how much? No, Salil, we are not able to use C is equal to 0.36 FCK into AST, because in this case they have changed certain things. They have changed the stress block parameter diagram. They have changed the partial factor of safety. So you need to use a basic concept, and that I have discussed over here, right? How to find out this particular value. So XU is equal to how much? How much you are getting? XU is equal to 76. Very good, very good. 76 mm approximately. So that's why, guys, our answer will be A. A is the correct answer. A is the correct answer. I think all of you are able to understand this. All of you are able to understand this, right? Next question. Next question. So guys, this is the problem, which is basically a doubly reinforced beam question, right? In which you need to find out the neutral axis again. And in this question, you need to just use a direct formula. And I think all of you know that particular formula, right? All of you know that particular formula, right? In case of doubly reinforced beam, what will be the formula? Do you know that, guys? C1 plus C2 is equal to T. What is the value of C1? 0.36 FCK B into XU plus, you know that this is FSC minus 0.45 FCK into ASC is equal to 0.87 FY into AST. Now tell me, guys, what is this value of FSC? In this case, they have not given any table, any value which we can use directly. But they have mentioned a statement over here. You need to assume the tension and the compression steel yield at the same time. That means this value will also become 0.87 Fy. Clear? 0.87 Fy. So I think all of you know this particular formula. Tell me, guys, all of you know this formula or not? All of you know this particular formula or not? Tell me, guys. Some student may think, sir, these questions are a little bit lengthy, but guys, to be true, in your examination, you may find such type of questions also, right? So you need to have some patience, okay? क्वेश्चन सॉल्व करते समय थोड़ा अपने आप को कंट्रोल करो, करना पड़ेगा, करना ही पड़ेगा, कुछ भी कर लो, राइट? अगर आप ऐसा सोच के बैठे हैं कि गेट में क्वेश्चंस जो आएंगे वो चुटकियों में हो जाएंगे, तो ऐसा नहीं होता है, राइट? You will get both the type of questions, like 1 mark questions also, 2 mark questions also. Some questions are lengthy, some questions are easy, right? So you will get a mixture of it. So while practicing, you need to give your focus, right? Okay, all of you know this formula, right? So just put the value and get the answer. Okay, I'm solving it directly. 0.36 FCK is 20. B is equal to how much? 300. XU we don't know, plus now this particular value will become 0.87 Fy. Fy is equal to 250. In this case, do not put 415. It is 250 in this case, right? So 0.45 FCK, FCK is 20, multiply by ASC, ASC is 628. 628 is equal to 0.87 Fy. Fy is equal to how much? Fy is 250. Multiply by AST. Multiply by AST is equal to how much? 2200, right? If you solve it, you will get your answer. XU is equal to how much? I think you are getting 160.90 mm, right? Approximately. You can solve it. Okay. So the answer is C, correct? The answer is C. You can check it out, guys. Okay. So let's move to the next question. Very simple question. Next question is very simple. I think it should be a 1 mark, right? 1 mark problem. 1 mark problem. In one line, you will get the answer. In one line, you will get the answer. There is a rigid frame, ABCD. AB member is a overhang member, right? And with end A being free, support C and D are fixed. Okay, no issue. DB is vertical member, BC is horizontal member. But guys, in this problem, we do not need to draw the figure. It is not required, right? Because our task is to find out the rotation at B, right? And you know that at the joint, at any joint, we have a joint equilibrium equation that is basically summation moment is equal to 0. Now you know that, guys, whatever moment, whatever the value of moment in the member which is related to the joint B, we need to write that and take the summation of it and ultimately make it 0. That's it, right? That is the logic which we need to use. So do not go into the detail of the figure. I can draw it, but it is the wastage of time in the examination, right? So the summation moment at B should be equal to 0. So can I write it directly? MBD plus MBA. If you want to understand, I will draw the figure also, but you can write it directly also. This is equal to 0. Very simple. So what is the value of BD? 0.8 EI into theta B. BA 54. BC minus 135 plus 1.6 EI into theta B, and it should be 0. Just solve it, you will get the answer. Theta B is equal to 33.75 divided by EI. This is the answer which we are getting. B. All of you are getting the same answer? Tell me, guys. Yes? I think sometime the comment which I am getting over here, it is little bit late, right? Yes. Okay. Okay, Santu, Ritu, Naresh, very nice, guys. I think all of you are getting the same answer. That is basically 33.75 upon. Okay, next question. Now, guys, this is the next problem, which is based on stiffness matrix, and again, little bit calculative. But if we are able to get a single value, then we can put the answer directly, right? Because you can see here, guys, we have 4 options, right? In which the first element, in case of first element, all first element are different, right? So you can see here, guys, if you are getting the value of single element, which is K11, then you get the answer, right? So do not get fear from these type of questions also, right? Whenever you find, listen carefully, let me tell you one hint over here, guys, or let me tell you one methodology which you can use in the exam so that you can understand whether the problem is difficult or not. Okay, listen carefully. First, what you have to do, you have to read the question, right? Whatever data is there, whatever figure is there, read it, no issue, right? And after reading it, what you will feel, it may be possible you may get 3 things, right? 1, it is easy. Second, I'm not able to solve it. It may be possible आता है नहीं आता वाली condition. And third condition is that in which you don't know, right? Completely. So there are 2 scenarios right now which can be beneficial for you. If you don't know the logic or not able to solve the problem, वो तो condition ही अलग है. अब यहाँ पे हमारे पास 2 चीज बची है. I'm able to solve it, I know that, or it is little bit confusing, right? So what you can take the support of options, right? So just try to understand the options also, right? Try to understand the options also. Just read the options, right? It may be possible sometime you will get the answer directly without solving it also, right? And it may be possible sometime you may get a logic from the option also to get the answer quickly, right? As I told you earlier also, guys, in this particular problem, I'm trying to find only a single element, not a complete solution, right? If you are able to get the first element, then you are able to get the answer. Clear? That is the logic which we use over here, right? Please ध्यान रखना ये चीज, है ना? बड़ी काम की बताई है मैंने, आराम से बताई है, काम की बताई. Okay, so first what you need to do, remove all the loadings, okay, and try to draw the figure. And we knew that, guys, in this case there are 2 coordinate direction, 1 and 2. So we have 4 element, right? So we will get a matrix of 2 cross 2. 2 cross 2. So our task is to find out K11, K12, K21, K22. But for solution part, we need to give focus over K11 only, right? Clear? Okay, so let's solve it. So guys, as per stiffness matrix, what we need to do, you can see here, guys, this is basically column 1 element and this is column 2 element. So what is the common thing over here? 1, right? 1 is common. So can I say that we have to give a unit rotation in direction 1 only, and lock other coordinate direction, and find out the force developed in direction 1 and in direction 2. Clear? So guys, basically we have 2 directions, coordinate direction 1 and 2. So first I will try to lock the second direction, because as per our statement we need to do it. So this particular support will become fixed, and give unit rotation in direction 1 only. That means theta is equal to 1. If theta is equal to 1, you have given over here, then this particular beam is, sorry, this particular column is trying to deflect in this manner, and this particular beam is trying to deflect in this manner. Now the question is, sir, what will be the value of K11? So K11 is nothing as, it is the summation K, the summation of stiffness, which we need to apply over here. So that, or summation of, you can say that the moment value which we need to apply over here, so that this joint can be rotate by theta is equal to 1, and that is equal to summation K, correct? So summation K we need to find. So this is 3 EI, this is EI, this length is 6 meter, this length is 4 meter. Let me write it properly so that you can understand. So this is basically 6 meter, guys, and this one is 4 meter, correct? And this value is 3 EI, and this value is EI. Okay. Now, guys, what is the stiffness of this member? Very simple. Let me write it, summation K, K1 plus K2. Consider this one is K1, this one is K2. So K1, far and fixed, 4 EI. EI is 3 EI divided by L. L is equal to how much? 6 plus K2, far and fixed, 4 EI. 4 EI divided by how much? 4. Cancel it. Cancel this one. Cancel this one. Ha ha ha. Very nice. We are getting a value of 3 EI. That's it. The answer is B. The answer is B, not C, not A, not D. The answer is B. Clear? B. Santu, we are getting an answer as a B, right? Not A यार. A कहाँ आ रहा है बच्चे? B आ रहा है ना? B आ रहा है ना? Correct ना? Okay. Now tell me, guys, whether the problem is difficult or easy. It is easy, yaar. It is easy. It looked like difficult, but it is easy, right? So try to give focus over the question. Then, if you are not able to get the question properly, or if you need some support, you can take the support from the option also. Very simple question. DS and DK. Need to find DS and DK. I'm not solving it. I'm trying to calculate it in my mind. Okay, let me do it. B. No issue, no issue, no issue. Tell me answer, guys. Tell me answer. Tell me the answer of this one. I have solved it in my mind itself. Okay. B. B is the answer. If you are getting the same value, please let me know. For the following frame, the number of static and the kinematic indeterminacy, ignore the axial deformation. Hinge or roller? It is roller support, roller support, roller support. B, 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 B. कुशाग्रा बच्चा B है. B के मतलब roller support है, sorry. Okay, very easy question, right? So let me solve the kinematic indeterminacy first. Okay, then we will solve the static part also. Okay, so theta 1, theta 2, theta 3, theta 4, theta 5, theta 6, theta 7, theta 8, theta 9, theta 10, theta 11, right? And this particular support can roll in this direction and in this direction also. So how much it is? 11 plus 2, 13, right? 13, then sway, 14, 15, 16. That's why DK is 16. Clear? DK is 16. Now what about static indeterminacy? We have 4 closed loop. So DSI is equal to how much, bacha? DSI is equal to how much? 3 into 4 minus 0. So it will be 12. What about DSE? DSE is RE minus 3. So in this case, we have this particular support as a fixed, which have 3 reaction, roller 1 reaction, roller 1 reaction. So 5 minus 3, that will be 2, right? So if you add both the values, you will get the value of ds, that will be equal to 14. So 14 and 16 is the combination, and that's why B is the correct answer. Clear? I think guys, this topic is very simple, okay, which means kinematic and static intimacy. So we have solved this problem quickly, okay, and I'm not going into the detail of this particular analysis, right? हमने solve कर लिया है जी. आते हैं next question पे. Next question. A city is generating 40 mld sewage having 200 milligram per liter of BOD. The only sewage treatment plant in the city can treat 25 mld sewage with 80% BOD removal efficiency. Now both the treated and untreated sewage is to be eventually mixed and discharged into a river. Now the BOD of the blended sewage before discharge would be. Tell me guys, the answer for this one. Okay, I'm solving it. So we have 40 mld discharge whose BOD is 200 milligram per liter, right? Now we have two component of it. One is 25 mld which goes into the treatment plant, right? Which goes into the treatment plant, 25 mld, and the remaining part, which is basically 15 mld, it goes directly into the water body, right? So guys, this one is what? This one is basically our STP part. This one is STP. So STP will have an efficiency of 80%, right? So if it remove 80% of BOD, then how much BOD is remaining? Can I write it guys? 200 multiplied by 0.2. So the remaining BOD will be 40 milligram per liter. And the discharge will remain same. That is basically 25 ml. Now what about this one? In this case, there is no treatment. So 15 mld and we have a discharge of how much? Sorry, BOD of how much? 200 milligram per liter. Now eventually these two values or these two discharges are mixed together, and ultimately we need to find out the BOD of blended sewage, right? So can I write it down guys? Very simple thing. It is a weighted average. So let me write it BOD of mix, that is 25 multiplied by 40 plus 15 into 200 divided by total discharge, 15 plus 25. हाँ भाई कितना? 100. Very good, very good, very good. 100 milligram per liter. We are getting answer as a B. B is the correct answer. Very good Babu, very good Santu, very good other student also. I think बहुत से बच्चों ने सही आंसर दे दिया, right? Next question. Next question in front of you. Next question. Next question in front of you guys. Again, little bit calculative but interesting problem. Okay, little bit calculative but interesting one. We have a community, right? We have a community and we are taking a charge of 20 rupees per meter cube of sewage, right? For discharge in which the BOD should be 250 milligram per liter and the suspended solid of 300 milligram per liter. If the value is exceeding, right? So whatever value they have mentioned, these are the standard values. If these values are exceeded, then additional charge we will need to put, and the rate will be 0.5 rupees per kg of BOD and 1 rupees per kg of suspended solid. Now we have a chicken processing plant, right, which used to discharge 2000 meter cube water per day, and discharge wastewater would have 480 milligram per liter of BOD and 1530 milligram per liter of suspended solid. Now guys, the cost will be what? You need to find out the cost, right? So let's solve it. Okay, let's solve it. So guys, first I will try to calculate the rate which is to be applicable at this particular per meter cube of discharge. Okay, चलो तो पहले इसको देख लेते हैं, right? As per this particular condition for a standard value. For standard values, whatever standard values they have mentioned, according to that, what is the cost for the discharge? Okay, first we will calculate that. Okay, so can I write it down, guys? This value is 20 rupees per meter cube multiplied by what is the discharge over here? 2000 meter cube per day. If you multiply it, how much you will get? 40,000 rupees, right? 40,000 rupees per day, correct? But in this particular cost, we are trying to treat this amount of discharge with the value of BOD is equal to 250 milligram per liter and suspended solid this much. But we know that, guys, in our wastewater, the value of BOD and the value of suspended solid is little bit higher, right? So we need to calculate that cost also. So first, let's calculate the exceeding value or excess BOD. Excess BOD. So our value is 480 and the permissible is 250. But these values are given in milligram per liter and the rate is given in terms of 0.5 rupees per kg. Okay, so we need to convert this value in kg also by multiplying discharge. So how much discharge we are treating? 2000, right? But this 2000 is in meter cube. So we need to multiply with 10 raised to power 3. So it is converted into liter per day. And this one is in milligram per liter. So you can cancel liter to liter, but this value we need to convert into kilogram. So 10 raised to power minus 6. So it will convert it into kg. 480 minus 250 multiplied by 2000 multiplied by 10 raised to power 3 multiplied by 10 raised to power minus 6. So we are getting a value of 460 kg per day, right? Now, what is the rate? Rate, or you can say that charge over excess BOD. Let me write in this manner. Charge over excess BOD. Excess BOD. So the rate of BOD is 0.5 rupees per kg of BOD. So 0.5 multiplied by 460. If you solve it, you will get 230 rupees or 230 bucks, right, per day. Okay. Now, similarly, we need to solve the second part, which is excess suspended solid. And that is equal to how much? 1530 minus. This is 300. Again, multiply by discharge. Multiply by 10 raised to power 3. Multiply by 10 raised to power minus 6. If you solve it, how much you will get? Two four 60 milligram per liter, right? Milligram per liter. Sorry, not milligram per liter. Kg per day. This value is in kg per day. Kg per day. Now, what is the charge over excess suspended solid? So that will be, the rate is 1 rupees now, 1 rupees. So 1 into 2460. So this value will become 2460 rupees per day. Now add all the values, you will get your answer. तो ठीक है भाई. So 40,000 plus how much? 230 plus 2460. If you add all these values, how much you will get? 42,690 bucks per day. भाई ये तो बहुत ज्यादा हो गया यार, आप समझ रहे हो, right? If you have a chicken processing plant and you need to give a charge of 42,000, मतलब means 43,000 per day as a waste disposal cost, right? You can't believe, guys, this question, this particular cost is very huge, right? Okay, no issue, but we need to give it. देना तो पड़ेगी भाई, है ना? Next question, very simple one. Match the following. You have to list 1, list 2. Let me know the answer. ठीक है भाई, जरा बताओ जल्दी से आंसर इसका क्या होगा. Tell me the answer of this one, guys. We have basically list 1 and list 2, right? And we need to match it. We need to match it. I think all of you know that, guys. Trickling filter is an attached growth system. Activated sludge process is an aerobic process. So we can say that for D it should be 4, for 3 it should be C. Settling tank. In settling tank we are generally trying to design it as per the Stokes law, but the restriction is there, guys, with respect to the size part. The size should be less than 0.1 mm. Grid chamber, we are trying to remove the suspended inorganic matter. B, correct. घाटे में चल रहा होगा उसका, हाँ जी, बिल्कुल बिल्कुल बिल्कुल. तो कौन सा ऑप्शन हो गया? बी, बी, बी. 1 का second, that's why B is the correct answer. Next question, which is based on the oxidation pond, right? And just you need to find out the unit required, how many unit you need to use over here, right? And the restriction of area is given to us, right? And the BOD loading rate is also known to us, right? Influent BOD and affluent BOD part is also given. Okay, no issue. So let me solve it, guys. Let me solve it in front of you. Okay, so can we calculate the total area which we need over here? Total area, can I write it down? Q into the BOD which we are trying to apply and the BOD which we are trying to get as the affluent part. Affluent and influent divided by BOD loading rate, right? BOD loading rate. Okay, so what is the discharge over here? That is basically 5 lakh. बहुत बड़ा discharge है भाई. Okay, 5 lakh liter, right? Do not multiply it by 10 to the power 3 or 10 to the power 6. It is already in liter. So liter per day multiply by influent BOD 150, affluent BOD is 15. Okay, and this value will become in milligram per day, right? So let me convert it. It is in milligram per liter and this one is liter per day. So liter will get cancelled, but we need to convert it into kg, 10 to the power minus. Okay, divided by 40, right? So if you solve it, you will get the area in hectare, the total area which we need. How much you are getting, guys? How much you are getting? Tell me. One 1.6875 hectare, right? Now we need to calculate the number of units. 1.6875 divided by area of 1 unit, which we have 0.9. So we need 1.875 unit, right? मगर ऐसी कोई यूनिट होती नहीं है तो 2 देना पड़ेगी. ऐसा होता तो नहीं है, मगर हो जाए तो बहुत अच्छी बात है। देखो क्वेश्चन एग्जैक्ट आना, डेटा एग्जैक्ट आना प्रैक्टिकली पॉसिबल नहीं होता। खुदा ना खास्ता कभी किस्मत रही, टू बी ट्रू गाइस, इफ यू हैव वेरी गुड लक, so you may find one or two question as a with same data, right? But to be true, it may be possible guys, you may get the questions in the examination with the same pattern, right? That is to be known as expected question, right? उसी को बोलते हैं expected, कि हाँ भाई इस टाइप के questions उम्मीद कर सकते, right? But not exactly with the same data. It may be possible the same concept will be there, logic will be there, which you can use, and related to this topic you may get the question, right? So that is known as expected. Okay, chalo ji, next question. A little bit different one, a different one. पैसा वसूल चलो जी, आ जाओ जी, पैसा वसूल फिर करेंगे। ओके, आइए फिर से करते हैं पैसा वसूल। ओके, पैसा वसूल की जगह मैं बोलूंगा कि भाई जो आप टाइम दे रहे हो वो वसूल होना चाहिए, है ना? आप यहाँ पे टाइम दे रहे हो, यू आर स्टडिंग ओवर हियर फॉर 1 hour, 1.5 hour, 2 hour approx, but you will get your content, whatever content you want. Okay, and if you are getting some confidence after solving these questions, then it will be beneficial for you, right? तो मैं बोलूंगा हाँ भाई फायदेमंद रहा। ठीक है, चलो जी, अगला क्वेश्चन बच्चों, देखते हैं क्या क्वेश्चन है जी, देखते हैं। After I think after 2-3 questions guys, you will get a simple one also, right? After that we will have simple questions. Okay, okay, let's come to this part. Okay, this one. So let's understand the problem first, then we will solve it. Okay, be careful while reading the question. There are two wastewater stream, which is A and B. A and B. This is A and this is B. Right? Right? And they have same BOD. They have same BOD. And they are getting mixed, and ultimately you will get a stream C. Right? The temperature of A is already given to us, which is basically 20 degrees centigrade. Right? And the temperature of stream C is already given to us, which is 10 degrees centigrade. Right? The 5-day BOD of stream A is 50 milligram per liter. So the BOD of this one is 50 milligram per liter, right? And the BOD rate constant with the base 10. That means KD at 20 degrees centigrade is 0.115 A inverse, right? The temperature coefficient, which is theta, it is 1.13. Now our task is to find out the percentage of ultimate BOD of stream C that removed after 3 days. So first, what you need to understand? We need to understand what should be the ultimate BOD of stream C, right? So just imagine guys, if the discharge of A is Q1 and the ultimate BOD is BU, right? As per the question, the ultimate BOD of A and B is same, identical ultimate BOD, correct? So that's why this is Q2 and this is ultimate BOD. Now this discharge will be Q1 plus Q2, correct? So can I say that guys, if you take the weighted average like this, or BOD mix, Q1 into BOD ultimate plus Q2 into BOD ultimate divided by Q1 plus Q2, that is equal to what? That is equal to BOD ultimate of C, right? So the same value is there which we have for A and B part. So the same ultimate BOD is applicable for C also. Clear? Now the question is, we need to find out the ultimate BOD for C, right? So we will use the data from A part and we will solve it. Okay, the temperature of A is 20 degrees centigrade and the BOD 5-day is 50 milligram per liter. So So for stream A, can I write it down, guys? The BOD 5-day at 20 degrees centigrade is equal to BOD ultimate bracket 1 minus 10 raised to power minus KD into T. This value is known to us, which is basically 50. Ultimate BOD, we don't know. Bracket 1 minus 10 raised to power minus KD 20 degrees centigrade, that will be 0.115. Multiply by duration, that is 5 day. Just find out the value of ultimate BOD first. So we are getting a value of 68.126 milligram per liter. So this is the value of ultimate BOD of A. The same value is applicable for C also. Now the question is, we need to find out the percentage of ultimate BOD of stream C removed after 3 days. So we need to find out the BOD removed after 3 days at 10 degrees centigrade. So for stream C, can I write it down, guys? First we need to calculate the KD value at 10 degrees centigrade. That will be KD value at 20 degrees centigrade, theta T minus 20, correct? So this value is known to us, 0.115, theta is 1.135, temperature 10 minus 20, right? Just calculate this one first. This value is coming around 0.0324 day inverse, right? Now let's calculate the BOD 3 day at 10 degrees centigrade is equal to BOD ultimate, right? Bracket 1 minus 10 raised to power minus K 10 degrees centigrade multiply by T. Guys, our task is to find out the fraction or percentage, na? Okay, percentage. Okay, we will find it out, no issue. So we will divide this particular value. Okay, so BOD 3 day at 10 degrees centigrade divided by BOD ultimate multiply by 100, you will get the answer. So this value is 1 minus 10 raised to power minus 0.0324 multiply by 3 day multiply by 100. Aha, आंसर आ गया जी. How much? The answer is 20.05%. This much amount of BOD is removed. Understood, guys? All of you are able to understand this? Okay, very nice, very nice. 20.06, Babu. Very nice, very nice, very nice. So I think all of you are able to understand this question. Okay. Next question, a simple one, right? A simple one which is based on the, again, pre-stressing condition, right? In which we have a permanent negative strain due to shrinkage and creep. So you need to just find out the final stress which is available in the steel. And this is a 1 mark problem, right? 1 mark problem. 1 mark problem. 1 mark problem. So first we need to find out the loss of pre-stress. How much loss is there? The losses of strain multiplied by ES value. So how much strain is there? Negative strain 0.0008 multiplied by ES. ES is 200 gigapascal. 200 into 10 raised to power 3. So that it is converted into megapascal. Okay. Let's calculate it. 200 into 10 raised to power 3 multiplied by 0.0008. So we are getting a value of 160 megapascal as a loss. So how much is remaining? Initially 200, loss is 160, remaining is 40. How you can say B? It should be C यार, it should be C. The remaining part, remaining बचा हुआ 200 minus 160 यार, that will be 40. 40, 40, 40, 40, 40. Next question, very easy, very easy. Tell me yaar, tell me the answer. The condition of short column, I think all of you know that, right? 1 mark problem. अब इतने बड़े बड़े सवाल करें, कुछ तो आसान मिलेगा, सबको खुश करेंगे, right? C. C. Okay. Very nice, very nice. We know that, guys, the condition of short column is what? Effective length upon least lateral dimension should be less than 12, right? But you need to calculate it in both the direction, whether it is X and whether it is Y. So mostly we are trying to find out the least lateral dimension. If least lateral dimension is B, so you need to check the LEX upon B value, right? If least lateral dimension is D, then you need to check LEY divided by D, right? So that's why, guys, the answer is C. Next question, tell me the answer. Tell me the answer. Consider the following statements. Consider the following statements. Just a second, just a second, just a second. I think this is a typo error. This is statement number 1. This is statement number 2. And this one is statement number. Yes, Mayank. I am from SGS ITS Indore. यही है, संतु कहीं नहीं गए स्टेटमेंट. ओके एमी, वेरी नाइस. मतलब काफी बच्चे हैं जो SGS ITS से हो सकते हैं, नो इशू. बढ़िया है बच्चों. D, okay, none of this. Very nice. Shamda Naresh ji. Babu C. Santu D. Very nice. बहुत शानदार. Let me explain it. In case of under reinforced section or under reinforced concrete beam, the actual depth of neutral axis is more than critical depth of neutral axis. How it is possible? XA value should be less than the critical depth of neutral axis in case of under reinforced section. That's why the statement number 1 is wrong. In case of under reinforced section, which particular material is fail? That is basically steel, not concrete, right? So you can see here, guys, the concrete reaches the ultimate stress prior to steel reaching the ultimate stress, right? So we can say that, guys, this statement is wrong. This statement is wrong. Right? Now, if we talk about the third one, the moment of resistance is less than the balance section. Yes. MR for under reinforced section is less than MR for balance section. So the first statement is correct. किस बच्चे ने आंसर दिया? C. Okay. 1 and 2 are wrong, but 3 is correct. Right? 1 and 2 are wrong, but 3 is correct. बाबू मैं यहाँ पे एक पॉइंट ऐड करता हूँ. देखो बच्चों, कभी भी लाइफ में आपने कोई डिसीजन लिया है ना, कोई भी डिसीजन लिया है ना, हो सकता है वो उस पॉइंट ऑफ टाइम पे गलत लग रहा हो सकता है आगे जाके गलत लग रहा हो, मगर मैं आपको बताऊं ना, अब जब सारे पीछे की चीजें मिलाओगे ना, तो अल्टीमेटली आपको ये लगेगा कि आपने जो भी डिसीजन लिए थे सब सही थे, कहीं ना कहीं से वो सही निकल के ही आए, है ना. तो वॉट एवर डिसीजन यू आर टेकिंग इन योर पास्ट और इन योर फ्यूचर, राइट, ऑल द डिसीजन एट द एंड ऑफ द लाइफ विल बी करेक्ट, है ना. आपके आखिरी जो समय होगा ना, उस समय आपको सारे डिसीजन आपके सही लगेंगे. ये फैक्ट है है ना, ये मैं चीज़ मानता हूँ, है ना, तो मैं आपको बता रहा हूँ। तो मैंने भी कई सारे डिसीजन लिए हैं जो पॉजिटिव भी रहे हैं, कभी नेगेटिव भी मुझे लगे हैं, बट वो एक ड्यूरेशन पे लगता है, बट एट द एंड ऑफ द लाइफ यू विल नॉट रिग्रेट इट, आपको रिग्रेट नहीं होगा। हाँ, अगर वो पॉजिटिव हो, ऐसा नहीं कि नेगेटिव डिसीजन ही हो हर चीज़ में, कि नहीं भाई मैं तो चोरी करूंगा, तो भाई ये तो साफ है दुनिया की नजरों में तो चोरी गलत ही है ना, तो वो वाली बात नहीं है ना। तो हो सकता है चीज़ें, ठीक है। अब छोड़ो यार, कहाँ बैच कहाँ बैचों की बातें चल गई यार, SGS ITS बातें कर रहे हो। चलो क्वेश्चन की बातें करते हैं, आओ। राइट, नॉलेज नॉलेज खेलते हैं। टेल मी द आंसर ऑफ दिस वन, वेरी सिंपल क्वेश्चन। Tell me the answer of this one. What is the net force that block experience? Tell me, guys, what is the net force that block experiences? The coefficient of friction between the block and the table. There are two coefficient of friction which is given to us. One is static, second is kinetic. 0.8, 0.6. If the horizontal force is 100, then what is the net force that block experience? Tell me. बच्चे, मयंक, एक्चुअली मैं GSITs में टीचर नहीं था, आई एम अ स्टूडेंट, राइट। और मैं काफ़ी लोगों से पढ़ा हूँ वहाँ पे, बट वॉट एवर टैलेंट यू हैव, इट विल ग्रो विथ टाइम, राइट। मुझे भी नहीं पता था आई विल बिकम टीचर इन फ्यूचर, मुझे नहीं पता था, टू बी ट्रू। मैं कॉलेज में ये नहीं सोचता मैं टीचर बनूंगा। समय आपको बना देता है, और समय आपको सिखाता है कि आप में अंदर क्या है, राइट। तो टीचिंग एक, मतलब मुझे पसंद है, इसलिए मैं इसमें हूँ, है ना। मतलब कोई जोर जबरदस्ती नहीं है, फाइनेंशियल बर्डन के कारण नहीं हूँ, या किसी और रीजन के कारण नहीं हूँ कि मैं टीचर बनूं तो मुझे इससे फायदा होगा, नहीं। टीचिंग मेरे अंदर है, मुझे पढ़ाना अच्छा लगता है, दैट्स व्हाई आई एम टीचिंग, राइट। इसका और कोई रीजन ही नहीं है ना। बस पसंद है तो पसंद है, दैट्स इट। ओके, सो टेल मी द आंसर ऑफ दिस वन यार। टेल मी द आंसर ऑफ दिस वन गाइस। 40। ओके, वेरी नाइस। So let's understand, guys, how we can solve this problem. चलो, बहुत बहुत बढ़िया, वेरी नाइस। अगर मैं आपके लिए एक इंस्पिरेशन हूँ, सो थैंक यू सो मच, अच्छी बात है। एक मानवता और एक जो इस दुनिया में एक्चुअली में भगवान ने जो हमें रचना करी है ना, वो इसी चीज़ के लिए करी है कि हम जो कर रहे हैं, है ना, वी आर द क्रिएशन ऑफ गॉड, राइट। तो हम जो कर रहे हैं, और जो उसके और क्रिएट, मतलब जो क्रिएट करा है उसने, जैसे आप मेरे से उम्र में छोटे हो, तो भगवान ने आपको बाद में बनाया होगा, और मुझे भगवान ने थोड़ा सा पहले बना दिया। तो मेरा काम क्या है, जिन्हें बाद में बनाया है उन्हें सिखा के आगे बढ़ाना, है ना, ताकि वो एक स्टेप और आगे बढ़ सके और आगे चल सके। तभी तो हमारे माता पिता हमें सिखाते हैं, आगे बढ़ाते हैं, हमारे गुरु हमें सिखाते हैं, आगे बढ़ाते हैं। क्यों? क्योंकि ये क्रिएटर ने ही सोच रखा है कि उसने उसकी क्रिएशन को ऐसे बनाया है कि आप अपने छोटे जो होते हैं उन्हें सिखाएं और आगे बढ़ाएं, उन्हें आगे ले चले, है ना, उन्हें पीछे ना करें, है ना। तभी तो भगवान की क्रिएशन का मजा है, और भगवान हमें सुख और सब कुछ देता है जी भाई, है ना। तभी आपको लाइफ में सब कुछ मिलता है। बहुत सिंपल सी चीज है, मगर लोगों को समझ में नहीं आती है। लोगों को समझ में क्या आता है, इसको बीट करना है, इसको पीछे कर देना है, इसका नुकसान कर देना है, ये सब चीजें छोड़ दीजिए, राइट। तो जो एक बेसिक चीज है वो आप फॉलो करोगे, लाइफ में अपने आप आगे बढ़ जाओगे, कुछ करने की जरूरत ही नहीं है, क्योंकि भगवान का फोर्स आगे की तरफ लग रहा है, ठीक है। अगेंस्ट मत करना काम, ठीक है। चलो यार क्वेश्चन पे बढ़ते, नहीं तो 30 तो छोड़ो, 25 भी नहीं हो पाएंगे अभी। Okay, चलिए. Okay guys, so let me solve this particular problem, right? So this is our surface, right? And this is the block which have a mass of 10 kg, right? Now we are trying to apply a force in this particular direction, that is basically 100 kilonewton. Oh, sorry, 100 Newton, right? Okay. Now you need to understand, guys, what is the net force that the block experience. So first you need to understand, guys, what is the value of limiting static friction force. That will be equal to mu into n, right? So what is the value of mu for static? It is 0.8 multiplied by n. N is equal to how much? Mg. So 10 into, you need to use 10 in this case, right? So it will become how much? 80 Newton. Now guys, if we take the kinetic friction, limiting kinetic friction, that will become mu k into n. So mu k is equal to how much? 0.6 multiplied by 10 multiplied by 10. So this is basically 60 Newton. Now the question is, listen carefully. Now the question is, in this particular case, this force is not greater than the limiting value, right? So we know that, guys, in this case, the block will remain in rest. And if the block is in rest, then we need to apply the static friction force. So the static friction force is 80, not 60, right? So the static friction force is 80. So the net force which is to be applicable in this particular block is 20. अब बताओ, रेस्ट पे रहेगा ये? अब बताओ, रेस्ट पे रहेगा ये? Tell me, guys. Arey no, Baba, no. The 20 Newton force is trying to move this particular block in the forward direction. So what will happen? The static friction force is over. Now the kinetic friction force will come into the picture. So what will happen, guys? This 80 is not to be applicable in this case. Now the force will become 60 only, right? And that's why the final force will be 40. D is the correct answer. What is the answer? 40 is the answer. Clear? Okay, let's move to the next question. (40 Newton is the correct answer. Clear, guys? Okay. Tell me the answer of this one. The characteristic strength of concrete in the actual structure is taken as how much? So this is basically a 1 mark problem, right? Now we have some of the question which is basically 1 mark, okay? Not too much calculative, but easy one. The characteristic strength of concrete in the actual structure is taken as how much? How much you are taking the characteristic strength of concrete for the actual structure? A, FCK. Guys, listen carefully. I think all of you have seen the curves, right? So this is the basically stress strain diagram for the cube, right? And if you're considering the cube, the characteristic strength of cube is FCK. But if you want to find out the characteristic strength of actual structure, the actual structure characteristic strength is 0.67 FC. So this is basically valid for structure part. This is basically valid for cube part. ये डाउट तो बनता भी है. प्रीति बच्चा पूछ रहे हैं, सर आई हैव वन डाउट, स्टैटिक फ्रिक्शन इज मोर देन द काइनेटिक फ्रिक्शन. Listen, generally the static friction is more as compared to the kinetic, but why it is so? Why it is so? Listen. In case of static friction, just imagine, let us suppose there are two surfaces which are rough. This one is rough surface, this is another rough surface. So they have like a groove like surface, right? So what they have basically a contact between them. So in the static condition, this contact is very tight, or you can say that they have very good connection between them. So ultimately what will happen, if you're trying to apply the force, a greater value of static friction force you may feel, right? But what happens when the body is trying to move right? But the body is trying to break this particular joint, right, or this particular connection, right? So what you can see here, guys, after movement of this body, they will not get sufficient duration to connect it again, right? And ultimately this body is continuously trying to move over it. So in that case, you can say that the kinetic friction force value is lesser as compared to the static one, right? शशांक डेमो क्यों नहीं दे रहे अब? इसके रिगार्डिंग बच्चे आपका ना सपोर्ट टीम से बात करिएगा, उसका मुझे इन्फॉर्मेशन नहीं है बच्चे। डेमो की जरूरत क्या है, वैसे तो मैं आपके सामने हूँ, यहाँ पर डेमो भी आपको मिल रहा है, मगर मैं आपको बोलूंगा स्टिल यू नीड सम डेमो, so I suggest you can contact to the support team, they will give you some information regarding it. Okay. It is always Preeti. Next question. Next question. For a simply supported slab of span 12 meter. 12 meter. The limit state of serviceability, as per the limit state of serviceability, the minimum effective depth required so that it can be safe in the deflection criteria. That is the question. Please remember this point, Preeti. It is always that the static friction force value is greater than the kinetic one. Tell me the answer of this one. What will be the answer of this one? Minimum effective depth, which we need over here. I think all of you know this particular criteria, which is basically span upon effective depth criteria. And it should be less than or equal to A value. Right? And this particular A value will depend upon the support condition as well as some modification factor is there. Now let me tell you one thing over here, guys. If the span value is less than or equal to 10 meter, then in that particular case, the A value will become how much for simply supported beam? It should be 20, correct? But the span value, if span is greater than 10 meter, then this A value will get modified and it will become 20 multiplied by 10 by span, right? Now let's use this particular data and solve the problem. So span is 12 meter, so that will be 12000 in mm. D we don't know, less than or equal to A value. So A value is 20 into 10 divided by how much? Now you need to put the span over here in terms of meter. In this case, you need to put it in meter. Just find the value of D. It should be greater than or equal to how much? So we are getting a value of 720 mm. 720 mm. Correct? A is the correct answer. Next question in front of you. 720 mm is the correct answer. A rectangular beam whose width is 350 mm and having an overall depth of 700 mm, right? And a concrete grade of M20, and we have a grade of steel as a Fe415. The tensile steel is F5, number of bar of 20 mm dia, clear cover is 25 mm, ठीक है. Now we need to find out the tau c value. That's it. Tau c value, the permissible shear stress. So to find out the permissible shear stress, you need to calculate the percentage tension steel first. Okay, because this is a combination of percentage tension steel and tau c value, right? So first I will draw the figure. This one is 350 and overall depth is 700. 5 number of bars whose dia is 20. Okay, clear cover which we have 25. Okay, 25 mm. First, I will calculate the small d value. Small d will become 700 minus the dia of this particular bar is 20. So minus 20 divided by 2 minus 25. Calculate it. 700 minus 10 minus 25. So we are getting a value of 665 mm as a small d. Now guys, let's calculate the percentage tension steel. So AST divided by B into D multiplied by 100. AST is equal to how much? How many bar we have? 5. Multiply by pi by 4 multiply by 20 square divided by B. B is equal to how much? 350. Small d is equal to how much? 665 multiply by 100. Just solve this one. So we are getting a value of 0.675. 0.675, right? So guys, 0.675 as a percentage of steel, okay, means between these two things, right? So let's calculate by using interpolation. Okay, okay, let me hide myself. Okay, let me hide myself. Now guys, we have two conditions over here, percentage steel and tau c. So percentage steel is 0.5, then tau c is 0.48. And if this particular percentage is 0.75, then tau c is 0.56. Our task is to calculate the value of tau c. So this is percentage which is 0.675. So what is the value of tau c? That is the question. So just use the interpolation and get the answer. 0.48 plus 0.56 minus 0.48 divided by 0.75 minus 0.5 multiplied by how much? 0.675 minus 0.5. Just solve it and let me know the answer here. Let me know the answer. 0.675 minus 0.5. Okay, then multiply this particular value. So I'm getting a value of 0.536. Yes. Yes, Santu, you are correct. 0.536 Newton per mm square. Very good. Very, very good. Very, very good. Very good, Ritu. Very good, Santu. Very good, guys. This is the correct answer, right? Correct answer. Next question in front of you. We have to draw the ILD, the vertical support reaction at A. The vertical support reaction at A. Tell me the answer of this one, guys. Quickly. The ILD for vertical support reaction at A. Yes. A is the correct answer. Again, A is the correct answer. A is the correct answer. Guys, in this particular problem, you can understand we need to use Mueller-Breslau principle. Put the guided roller support and give unit displacement in direction A or vertical reaction A. So that means we need to give delta is equal to 1. So this particular support will try to travel in upward direction with delta is equal to 1. And the deflected shape of the beam is to be like this. That's it. A is the correct answer. Next question. Next question. The rise of parabolic arch at quarter point is equal to how much? The rise of a parabolic arch at a quarter point is equal to how much? This is a parabolic arch, and I think all of you know the formula of equation of parabola, right? This is h, which is central rise, and this is length L, which is basically our span. So I think you know that, guys. Y is equal to 4hx into L minus x divided by L square. This is the basic relation, right, of equation of parabola. Now in this case, we need to find out the rise at a quarter point. That means x is equal to L by 4, right? So y is equal to how much? 4 into h into L by 4 multiply by L minus L by 4 divided by L square, right? Just solve it, you will get the answer. Cancel this one, चीर दो इसको भी. So h into 3 by 4, right? 3 by 4 h आ रहा है क्या? D, 3h by 4. If you solve it, you will get answer as a D. Next question. What should be the force in CF member? What should be the force in CF member? What should be the force in CF member? Very easy question, very easy question. Just you need to take a single section, you will get the answer. You will get the answer. Zero. Very nice. You can see here, guys, this particular value will become W and this value will become W, right? And if you take this particular section, so what will happen? Ultimately, this particular member is trying to take the vertical forces, right? So we will take summation Fy is equal to 0. Whatever theta will be there, I don't know, right? Because in this case, they have not given any rise, or you can say that the height. So if you take this particular part as a summation Fy is equal to 0, so in this case, you will have plus W minus W plus FCF sine theta. That's it. And it is equal to 0. So FCF is equal to 0. D is the correct answer. Next question. The shape of cable under the UDL over the length of cable. बड़ा अच्छा question है. Tell me the answer of this one, guys. What will be the shape of cable under the UDL over the length of cable? The shape of cable under the UDL over the length of cable. Parabolic. बहुत शानदार. Very nice. Very nice. Very nice. Very nice. The answer is catenary. A is the correct answer. A is the correct answer. Listen carefully, guys. Listen carefully. A is the correct answer. Bhai, this is a parabolic cable. Okay. Listen, this is a parabolic cable. Okay. So when this particular shape will become parabola, when you have a UDL over the length of span. What is span? Span is nothing else, that is the horizontal distance between two support. That is to be known as span. Listen carefully. Horizontal distance between two support is known as span. But if you put the U, in this case, this will be parabolic. But just imagine, guys, if you put UDL over the length of cable, then the shape will become catenary. 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 Clear? सेल्फ वेट कैटेनरी है, मगर ये भी तो पढ़ो, कैटेनरी तो ये होगा UDL over the length of cable. So this is the length of cable. This is the length of cable. Cable का लेंथ ये है. This is the span. This is span. The horizontal distance between two support is span. This is length of cable. And if you put the UDL over the length of cable, you'll get catenary. Next, MSQ. Overflow rate of sedimentation tank. Tell me, guys. Overflow rate of sedimentation tank. Overflow rate. ABC. Okay. Listen carefully, guys. If we take the definition of overflow rate and surface loading rate, the definition are different to be true. The definition of overflow rate says the rate by which the water is trying to come out of the tank. That is called overflow rate. But if we talk about surface loading rate, what I mean by surface loading rate? The rate by which we are trying to apply, listen carefully, the rate by which we are trying to apply this any kind of water, right? Or you can say that sewage, right? So if you're trying to apply the discharge over a unit area, that is known as surface loading rate, the rate by which you load the sedimentation tank, right? But on the basis of formula, both the values are same. On the basis of formula, both the values are same. Overflow rate as well as surface loading rate. So we can call it as like A option can be a correct one, right? Can be a correct one because of formula. It is independent about depth of the tank. Overflow rate, you know that, guys, overflow rate, that will become discharge upon surface area, right? So it is independent of depth. Yes. It depends upon length and width. Yes, because this is length cross width. So A, B, C are the correct answer. Next question. After this, we have the last question, right? So you need to just calculate what percentage of particle that have a settling velocity of this one. What percentage of particle that have a settling velocity of this one will be removed? Will be removed. Very simple question. Need to calculate SOR or design settling velocity, which is discharge upon surface area. So how much discharge we have? 0.6. What is the surface area? 20 meter long and 6 meter wide. So 20 into 6. This is equal to how much? We are getting a value of 5 into 10 raised to power minus 3 meter per second. Correct? Now guys, our task is to calculate the percentage of particle which have a settling velocity will be removed, right? So percentage removal, that will be US upon SOR multiplied by 100. So what is the value of US? 0.003 divided by 5 into 10 raised to power minus 3 multiplied by 100. %. 60%. How much you are getting, guys? 60%. D is the correct answer. Now let's solve the last question of the session, which is again based on settling velocity of sedimentation tank. Settling velocity is typically highest under which particular condition? In which particular case you may find the highest settling velocity? Highest settling velocity. Tell me, guys. D. Compression settling. नहीं, वो तो पुराना है ऑप्शन. ठीक है संतु. Flocculant. Yes, it should be flocculent. It should be flocculent. Yes, it should be flocculent. Now let me explain why it is so. In case of discrete particle, what happened guys, the individual particle is trying to settle by their own weight, right? Because of their size is less, that's why the settling velocity will be less. But in case of flocculent settling, we have multiple particles which are connected together. So the size of particle will get increased, and due to that, the settling velocity will overall get increased. So that's why guys, you may find a highest settling velocity in flocculent settling, right? Flocculent settling. That's it guys. From my side, this is all about for today, right? Soon we will meet again. We will take some more session for your practice, right? I will plan something more for you guys, okay, so that you can achieve your dream. So this is the questions which we have discussed today, right? Which is moderate one, you can say that, है ना? ठीक ठाक थे भाई, बढ़िया थे, कोई दिक्कत नहीं है. But soon you will be get some more session regarding your GATE 2022, right? And definitely you will succeed in that exam. ये मेरी उम्मीद है और मैं प्रे करता हूँ आप लोगों के लिए, ठीक है? So thank you so much बच्चों, thank you so much, and I hope you have loved it, and we will meet soon, okay? We'll plan some more session for you for GATE exam again, and after that we will take some session for ESC also, okay? So if you have any query, any doubt, तो बता दीजिए. Okay, you will get the PDF on my Telegram channel. I will post it, okay? If you don't know my Telegram link, so let me share it over here. Let me share the Telegram link over here guys, okay? Just a second. But काफ़ी बच्चे जानते हैं, नहीं जानते कोई बात नहीं, मैं भेज देता हूँ जी टेलीग्राम लिंक. ओके, आई विल शेयर द PDF राइट नाउ. अभी भेज रहा हूँ तुरंत में, ओके? सेशन क्लोज करते साथ ही आपको PDF मिल जाएगा, ओके? So this is all about for today guys. Let's close the lecture and let's meet in next session, okay? And please utilize your time properly and effectively. It is my humble request to you, ठीक है? बहुत effectively utilize करो और अच्छे से utilize करो जी. आखिरी का समय है, कीमती है ना? बाय बच्चों, टेक केयर. So when we have to use 0.434 constant, in which thing? कहाँ पर संतु, कहाँ पर? Deoxidation constant. Listen, deoxidation constant में कहाँ 0.434 आता है भाई? ये तो बहुत ज्यादा बड़ा वैल्यू है. Listen, let me tell you one thing. Let me explain one thing over here. Usually what happen, the value of KD generally in between 0.05 to 0.2 day inverse, right? Now what happened, this is basically base 10, right? Base 10. Now just imagine guys, if you get any value which is greater than 0.2, right? And if it is not mentioned whether it is base 10 or base E, so what you can consider, you will consider that is base E. If it is not given, if it is given, then it is okay. If it is not given, then you can consider that is basically base E. If it is greater than 0.2, okay, greater than 0.2, okay. Now we have some criteria to change this particular value on the basis of temperature also. So KT degree centigrade is equal to K 20 degree centigrade theta T minus 20. Now this theta will depend upon the temperature. This is known as temperature coefficient. If the temperature is less than 20 degrees centigrade, then what, and greater than 4 degrees centigrade, then what you need to use? You need to use 1.067. If you have a temperature greater than 20 degrees centigrade, this particular value will become 1.135. और क्या यूज करना है इसमें? दैट्स इट, इसके अलावा इसमें कुछ है ही नहीं। 0.34 वो ऐसे हो सकता है, एक मिनट, वेट अ मिनट। लिसन संतु, I got it. Listen, what happened? Sometime you have a value of k which is base e, right? And you need to convert in terms of base 10. That is basically kd. So what you have to do, listen. What you have to do, listen. Just imagine if the deoxidation rate constant is 0.3, K inverse. If it is given to us, and I need to convert it in terms of kd with base 10. This is basically base e. This is base 10. So how you can convert it? By putting 0.3 divided by 2.303. Now if you divide it, so what you will get exactly 0.3 into this factor is nothing as 1.1 by 2.303. ये फैक्टर आप बोल रहे हो 0.4342, ये फैक्टर, ये 1 बाय ये होता है और कुछ नहीं है। दैट्स इट। Now it is clear. That is a conversion factor which you can use. Just use 1 by 2.303 so that you can understand it. Okay, so let's close the lecture and let's meet in next session. Okay, bye bye guys. Please download the BYJU'S Exam Prep. If you have not downloaded the app, please download it. Okay, bye bye bachcho, take care. Thank you so much for joining the session. Let's meet in the next session. Okay, bye.